We're going to add another identity. So this would be our fourth. So we have the reciprocal, the quotient, the Pythagorean, and now we're going to introduce the cofunction identities. And then we're also going to talk about angles of elevation and depression at the end. So we have a theorem which explains to us what the cofunction identities are. And the theorem is that cofunctions of complementary angles are equal. Now that's a mouthful. Let's talk about what complementary angles are, in case you've forgotten from geometry. Complementary angles means that if you have two angles, A1 and A2, they add up to 90 degrees. If they add up to 180, they're called supplementary angles. And then cofunctions, this is the best part. It's literally when you put the word co in front of. So if you have the sine of theta, its cofunction is cosine of theta. So cosine. If you have the secant of theta, its cofunction is cosecant of theta. Cosecant. And if you have the tangent of theta, its cofunction is cotangent of theta. Cotangent. And they're cofunctions of each other. So cosine is a cofunction of sine, and sine is a cofunction of cosine. So it goes in both directions. So what you do is you replace the angle with the complementary part. So for example, the sine of 30 degrees is equal to. So one of the key things here is that you have to change both the function and the angle. This is really important. So the complementary angle of 30 degrees is 60, and the cofunction of sine is cosine. So the sine of 30 degrees will be equal to the cosine of 60. They have the same ratio. Okay, the tangent of 15. So the complementary angle of 15 is 75, and the cofunction of tangent is cotangent. So the tangent of 15 and the cotangent of 75 has the same ratio. All right, I have the cosecant of, say, pi over 4. Okay, so I have to change both. So I have to find the complementary angle. So that might be a little bit hard in radians. So remember, what you're doing is you're trying to take it away from 90 degrees. And 90 degrees is pi over 2. So pi over 2 minus pi over 4. I need to do a common denominator. So I multiply this one by 2 over 2. So 2 pi over 4 minus pi over 4 is pi over 4. So this is pi over 4. And this is going to be secant. You could have also changed it to degrees. So hopefully by now you're getting comfortable and knowing that pi over 4 is 45 degrees. And the complementary angle of 45 degrees is 45 degrees. But even if you didn't, you could still do it with the radians by doing pi over 2 minus pi over 4. So these are the cofunction identities. So I'm going to go here real quick. And we're going to write that. I'm going to move this over. And I'm going to move this over. And I'm actually going to make this a little bit smaller. Perfect. Okay. So we're going to have that the sine of theta is going to equal to the cosine of 90 degrees minus theta. The secant of theta is equal to the cosecant of 90 degrees minus theta. And the tangent of theta is equal to the cotangent of 90 degrees minus theta. Now 90 degrees could also be pi over 2. So here are my cofunction identities. And I'm going to make a little note here, really important, and what people forget a lot. You must change the angle and the function. This is key. So this is really what you want to try to remember, and really what I see people forget, that you have to change both, okay? Okay, let's put it to the test. So here it is, our favorite instructions, find the exact value. Third video, third time we see this type of problem. So first you look to see if it's angles you know, which would be, so far, 30, 45, and 60. Because then you could draw the little triangles and just plug in the ratios. But 35 and 55 are not. So what I do notice is that these angles here are complementary angles. So together, they add up to 90. So what I can do is I can change them all to be the other one. So I'm going to keep the sign of 35. And I'm going to change the bottom. So I'm going to change 55 to be 35. But if I change the angle, I have to change it to its cofunction. And the cofunction of cosine is sine. So then they would cancel each other out, and I'm left with 1. Okay, let's look at the next one. So I have pi over 18 and 8 pi over 18. So pi over 18 plus 8 pi over 18 is 9 pi over 18. So this is pi over 2. So it's 90 degrees. So they're complementary angles. So these two are complementary angles. So I'm going to keep the secant of pi over 18 minus, and then I'm going to change 8 pi over 18 to pi over 18. But if I change the angle, I have to change the function, and the cofunction of cosecant is secant. So then secant of pi over 18 minus secant of pi over 18, the same ratio twice. You're subtracting them, would cancel each other out. Okay, let's do another one before we move on. So I take a look at the angles. I don't know 15 or 75. But what I do know about 15 and 75 is that they add up to 90. So they're complementary angles. So what I'm going to do is I'm going to keep the tangent squared of 15. And I'm going to keep the cotangent squared of 15. But I'm going to change these two. So I'm going to change the 75 to be 15. But if I want to change the 75 degrees to be 15 degrees, I have to change the function to its cofunction. And the cofunction of sine is cosine. So cosine squared. Okay, then I'm going to change the other 75 degrees to 15 degrees. But if I change it, I have to change the function of cosine to its cofunction, which is sine. So sine squared. So now everything is in 15 degrees. So I have something quite complicated, but what I notice is that some of them are in sine and some of them are not. So I'm going to use the quotient identity. So what I'm going to do is I'm going to change tangent squared and cotangent squared. So I'm going to work with these two terms separately. So tangent squared is sine over cosine. So sine squared of 15 degrees over cosine squared of 15 degrees times, and then I'm going to bring this down, so cosine squared of 15 degrees, plus, and then I'm going to change the cotangent squared, so cotangent is cosine over sine, so cosine squared of 15 over sine squared of 15 times, and then I'm going to bring this down, sine squared of 15 degrees. Now, when you don't have a denominator, there is a denominator, and it's assumed to be 1. We just don't write it. So when you multiply across numerator and denominator, but in the first term, the cosine squared 15 are going to cancel because 1 is in the bottom and 1 is at the top. And in the second term, the sine squared 15 is going to cancel. So I'm left with, in the first term, I'm left with sine squared of 15 degrees. And in the second term, I'm left with cosine squared of 15 degrees. But sine squared theta plus cosine squared theta, when the angles are the same, okay, because the angles are the same, you can use the Pythagorean Theorem. And the Pythagorean Theorem says that sine squared plus cosine squared is 1. So again, my goal for all three of these, remember what the goal was when you're doing these types of problems, is to get a numerical value for your answer. So you're trying to cancel or evaluate all of your trig functions. So you will have a numerical answer at the end. Okay, let's move on to angles of elevation and angles of depression. So we're going to be using these when we do word problems. And word problems and applications will show up throughout the semesters in different sections. So when you are staring straight ahead at the horizontal, this is 0 degrees. Okay, so you want to think about you, like when you're neutral, you're looking straight ahead. And you looking straight ahead is 0 degrees. Now, if you need to look up, looking up creates an angle of elevation, like how much you have to raise your head. And when you look down, this creates an angle of depression. Again, the key is that the horizontal is 0 degrees. What I will see many times, and what you want to be cautious of, is never do an angle of a depression like this. So your angle of depression never goes from your body. It always goes from the horizontal. So think about like a standard position angle. Like where is 0 degrees normally? That's going to be 0 degrees in your diagram. So let's do 2 examples. A tree casts a 10-foot shadow, and the shadow makes an angle of elevation of 25 degrees to the top of the tree. Find the height of the tree. Okay. So we have a tree. And the tree makes a shadow. Now, the height of any object always makes a 90 degrees with the bottom. Okay? That's just the definition of a height. And then you have the shadow. And it tells us that the shadow is 10 feet. It also tells us that it makes an angle of elevation to the top of the tree. So the shadow makes an angle of elevation. So it looks up to the top of the tree. And it makes an angle of elevation of 25 degrees. So if the shadow had eyes, it would be looking up and turning its head to the top of the tree. And it wants to know what the height is. So the height is this little guy right here. This is the height. This is what we're looking for. So we'll call this h. So what you do is you think about Sohcahtoa. So Sohcahtoa. So if we have our angle, 10 feet is the adjacent, and the height is the opposite. So if I have O and I have A, I want to use the toa part. And the toa part is tangent. So I have tangent of theta is equal to O over A. So I'm going to plug in what I have. The tangent of the angle, 25 degrees, is h over 10. I can bring this over, and I get h is equal to 10 times the tangent of 25 degrees, and I am in feet. And 25 degrees is not one of our golden angles. It's not 30, 45, or 60. So I can't draw a little triangle and figure out what the tangent is. So this is calculator ready form. So this is your final answer. You can't go any further. Let's do one more. You're standing on the top of a building and look down at a sculpture with an angle of depression of 45 degrees. The building has a height of 1,000 feet. How far is the sculpture from the building? Okay, so you're in a building. This is you. Yay. And you see a sculpture. Now, it tells you that the building is 1,000 feet tall. You need to look down to the sculpture because you're on top of the building. And then it wants to know how far is the sculpture from the building. So this is x. So again, this is when you would have to be careful. All right, I'm going to move this 1,000 feet here to be on the other side. So again, what a lot of people would do would put the angle of depression here. It's a very, very common mistake. But that is not correct because it has to go from the horizontal. So the angle of depression is this. This is 45 degrees. Now this makes a right angle. So this angle will be 45 degrees. So in this case, you would be lucky because 45 and 45 are complementary. So then we think about Sohcahtoa. Sohcahtoa. So this is the opposite. This is the adjacent. So again, we're going to use O and H, so we're using, again, the Toa by coincidence, which is fine. So the tangent of 45 degrees is equal to x over a. Oops, I know a. I shouldn't put a. A is 1,000. So I bring this over. I have x is equal to 1,000 tangent of 45 degrees. But I know the tangent of 45 degrees. So I draw my little triangle. This is 45. This is 45. This is 1, 1, square root of 2. So the tangent is opposite over adjacent. So the tangent of 45 degrees is 1. So 1,000 times 1. So x, the sculpture, is 1,000 feet away from the building. So the difference between the two final answers here is that in the first one, we don't know the tangent of 25. But in the second one, 45 degrees is one of our golden angles. So we can evaluate and find the ratio of tangent of 45.